Welcome to Letters from America, a road trip podcast searching for the Swedish heritage in the United States. I'm your host, Martin Wern, and today I've parked my Volvo outside the Rice University in Houston, Texas. And in my Airstream is Pernilla Wittung-Stafshede, or Stafshede.
Stafshede, på svenska.
Who is Stafshede, who is a professor in chemistry at the university. And also a former member of the Nobel Chemistry Committee?
Nobel Prize Committee for Chemistry.
There's a lot of titles here that
I know, it's too many names.
What would you like me to call you? How do you introduce yourself with all the education, all the titles that you've earned?
I typically say I'm a professor in chemistry.
Okay.
And then I have a shared professorship, so that has a name. And okay, I have a history with some degrees, but it's really where you are now.
Yeah.
Here in Sweden, everybody calls me Pernilla, but here they're a little bit more formal. So when you teach things, they typically call people doctor or something.
Ah, so you're Professor Wittung.
Professor Wittung or Professor Wittung-Stafshede, but I try to make it simple. Sometimes they call me Professor Pernilla.
But we're at this university, and you have your research department up on the top floor. I've just been there.
Yes.
How did you end up here?
Yeah, it's I don't know. It's a long story if you think about it, the whole
we have
thing.
Time.
It's a lot of coincidences, and I think it's a lot of me kind of pushing myself or being a little bit restless that I can't stay too long. It's at one place. I moved several times in my life. Maybe part of me wants. I want to test my limits, like how far can I go? But
why did you start in chemistry? What was that?
Well, that was also a coincidence. So I'm born in Sweden and I grew up in Sweden. And when I was a teenager and started at university, I was in Gothenburg.
Oh, yeah.
And then I knew about this university, Chalmers University of Technology. And I applied to programs there. And at that time, this was in the late 80s, I thought I liked physics because I was good at math and things like that. So I applied to the physics program and I put chemistry as a number 2.
All right.
But I didn't get into physics. Actually, I didn't get into chemistry either. So the first time I applied, I got nothing. And instead I went to the US as an au pair girl. So I was in California for a year taking care of a baby. Then I really wanted to go back to studies, actually. So it was good. I applied again the next year. I got in as kind of on the waiting list for the chemistry program. So again, stupid me, maybe. I put the same list of the two things I applied for. But I got into the chemistry program, and it's really chemical engineering. Really, in the beginning there, I didn't like the engineering part. The first week they show you around, like, company or factories or where they do engineering stuff or chemistry.
When you say chemistry engineering, you mean like for the industry, for the production of chemistry?
So in Sweden, you have these engineering programs, or you have more traditional kind of science programs. So Chalmers University has only engineering programs. So that gives you like a special title. So that's always considered a good education. So I thought I would do that. I mean, when I was young, I didn't know what I wanted to do at all. I just wanted to study something that gave me a lot of options, I think. So it became chemistry and chemical engineering. But then in the last few years, you can kind of pick your courses a little bit. So then I picked more basic chemistry or like non-engineering things. And I think the key thing there is that the last year of those 4 years, you could apply to study abroad. Yeah. And I thought about that already from day one, actually, that, I want to go away. I think I always liked traveling.
Yeah.
So then, and I got in. So I went to Imperial College in London. And I was a student there for a year. And they put me in a program that was about research. I had no idea. We took a boat to UK you didn't have much contact. So I didn't know what I was supposed to do there. I came into the university and they said, hey, you're going to work in a lab now. So that's when I saw what is research. And
that's like another door, another possibility is opening.
And I fell in love with it. It was really hard because there was so many things in a laboratory environment that I didn't know how to say in English. So it took me time. And this about But the fact that you do experiments and you explore like new things that nobody has tried, and I'm like the first one to discover things, and then I have to make sense of that to figure out what it means. So anyway, and that showed me, or I learned there, that you can actually continue after your degree and get something called a PhD. So then I went back to Sweden and I applied for PhD positions at my former university, Chalmers. So then I did my PhD in physical chemistry. And I picked that because that professor, I had him in physical chemistry as an undergrad. And I really liked him. He was this lively professor explaining, you know, entropy and things with his hands. And he was really, it felt like that's a good place. And then I got to work on some projects. You know, I worked on DNA. I worked on some DNA analogs that could be genetic drugs in the future. I did a bunch of experiments with a lot of different techniques. And I really liked it. And I think I was probably good at it too. And because I pushed myself. Because that advisor, he wasn't really following up what I was doing. I mean, I was doing things and I went to him and said, look at this, and now I saw this, or I did this, what do you think? You know, I've written this, what can you edit? You know, I pushed him maybe, but I learned a lot.
Yeah.
So now
it's a different method also. You learn a way of thinking. It's almost like creativity in a way that you learn.
You have to be very creative, you know, so that's
and
why.
And also open for whatever answer comes your way.
And that's the key. And that's why kind of, you know, thinking about the big picture of research and having, you know, unrestricted funding for research. But you need to have the possibility to like test whatever goes weird, right?
Yeah.
The strangest result is really the most interesting one. If you know what you're expecting, it's kind of boring science. But if you really explore, anything can happen.
Like a detour.
And that's many times how great discoveries are done. I mean, you find something new. Think about penicillin, you know, that guy, he didn't look for an antibiotics. I mean, he looked for something else. And this was a side reaction and, oh my God, what is this? And he followed it up. So I think it's important to be in the right kind of creative mode or in a happy mode when you do research.
Yeah, like an openness.
Yeah.
I can see that, yeah.
And I really like that. This is about like being my own, it's up to me. I mean, it's a big responsibility. And it still is. I mean, you've never done when you stay in academia, being professor and working at university. I mean, you always need to like, you know, success is very short term.
Yes.
And then you need something.
You always need
new.
the next thing, the next step.
But anyway, getting my PhD, the next step will be called a postdoc.
Yeah.
And then I applied for Swedish money to go abroad. So I got funding from the Research Council in Sweden to go abroad. And I went to California, to Caltech, or California Institute of Technology, like one of the top schools in the US. And I went there because it was a really good professor there that was working on something interesting. So I had...
Where are we now in your life, in your age?
Now I am... I'm 28.
Okay, so you've done a lot of studies and then...
Yeah, I mean, I got my undergraduate and that included the master, and then I got a PhD. Then I go away for this postdoc, which is more like a job, right? But still, you're still learning and you're still kind of not independent because you work in a group of a professor. So it's somebody else's research group. But that's kind of the first step to become independent. And at that time, I just thought I get 2 years in the US, I can have fun, right? I want to go somewhere I can do great science, but I also want to explore. In California, you have beaches, you have mountains, you can drive to state parks. I mean, it's beautiful. It was good. I think I was doing well. And then I just realized from the other people in my lab that, the other postdocs, they are applying to become professors. I didn't really know about this pathway. It's like I didn't think that far ahead in my early life. I was just kind of enjoying the moment, I think.
How do you become a professor?
You have to apply for a job. So every fall, there are a bunch of applications or openings at different universities. They look for assistant professors, which is the first level. So then, if you get that position, you start your own group. You get a lab space and you fill it with instruments and you recruit students that work in your lab. At the same time, you need to do teaching and duties to the university too. But the key thing to be a good professor is that you do great research, right? And you have your own topic that you work on. Then with time, you can get promoted. You get tenure, which is this kind of, permanent thing. Then you become an associate professor. And then you can be evaluated again and you become a full professor. So that's like the steps of
How much time do we talk about here?
I mean, 5-6 years for the first step, assistant professor.
Oh,
then
wow.
maybe the same amount of time on associate level, and then you become full professor. And a lot of things in academia, we evaluate each other. You know, because there's no like numerical system you can say that's good and that's bad, that's interesting. You need to have reviewers that, you know, different other researchers that kind of volunteer and do certain things. So we have to do these duties. Sometimes I review things for some type of grants, right? And then I apply for other grants. And so it's a lot of that we always judge each other, which sometimes it's hard to find a better system, but you can also, you know, misuse that system if you want to.
I see before me, maybe, you know, ruined by all the drama of television and hospitals and all that you see. Is there like a competition within this group?
I mean, there are competitions.
Can we make a TV show out of this?
Yes. I think you could actually make like some kind of soap opera about the academics at universities and how typically you don't compete with people here. I don't compete with the other people at RISE.
Oh, you compete with
I compete with other people doing similar type of research as I do at other places, right? You want to
keep tab of each other where you... All right.
You know, it's different in different fields.
Yeah.
When I started out, we were working on protein folding, and that's a very competitive field. And there was different kind of groups and people that came from different professors that had, you know, there was always like a fight.
Can you explain that? Protein folding.
Yeah. Typically, I have a rubric snake.
Oh, yeah.
And that's my illustration. You have a long rubric snake, and that's kind of a protein chain, and it has to curl up to some compact structure. That is the functional form of the protein. So this process of going from the extended form to something globular, that is called protein folding.
Okay.
And this happens in us all the time. So we make these kind of boiled spaghetti. That's my other kind of illustration. And then you roll it up to a yarn ball.
Oh, yeah.
But how does that happen? How does a boiled spaghetti know what to become, right? And that has puzzled researchers for a long time and still does, although we know more and more. But to understand more about that, you need to do experiments. You need to study proteins and figure out this protein, that protein, you know.
Which leads back to the backstabbing and the intrigues of the research work.
Yeah, and then, you know, people can have different opinions because even if you try to do controls and you do correct experiments, depending on how you do experiments, you know, people come to different conclusions. That's why we have so many researchers and do rather similar things sometimes, because we need to kind of double check each other and compare and see, but you had a different pH or you had a different buffer or you used that method. You know, if we can, eventually everything comes together to some kind of truth, right? Or the scientific kind of reality there. But there is indeed competition, because if you think about the funding, not all of us get money all the time.
No, of course. As soon as there's money into something, there's competition.
And the success rate of applying for funding can be like 10%, 15%.
Yeah.
A lot of people don't get the money they try to get. And you have to apply again and again. You know, that makes it competitive. And it's competitive in getting to publish too, because you need publications. And then there you also have reviewers. Yeah.
So you're in California now?
So now I'm in California.
Yeah.
And I heard about being a professor. So I applied for professorships. And I applied to maybe 10, 15 different positions that were open at different universities. When I came to the US, I was very naive. I was Swedish and I thought, you know, I'm here to kind of, as long as it works for me, I'm here in the US. And if I fail, I go back to Sweden. So I applied probably too early, already in my first year as a postdoc. Because why not? I can test the system,
course,
right?
Why not?
And then I started to get called for interviews. So then I suddenly have to think about, what do I want to do as research, right? It's like you need to have a research talk, what you've done, but also proposals, what you plan to do if you were to be hired.
You need to present a plan of why.
So I made up some crazy ideas. Oh my God! Now I still have them, so I can. Sometimes I look at them, and I use transparencies at that time. That's how you show things. But I was interviewing at 3 places. And one of the places were New Orleans, Tulane University.
Oh, yeah. They were searching for a professor.
So all these places were searching. And like RISE here searches for several professors every year. That's kind of a normal thing. But then I went to these interviews and Tulane gave me an offer.
Yeah.
Oh my God. So I got this offer, and that was my first interview. So I didn't remember anything about the place. I had to go back again and look like a second time because it felt like, oh my God, now it's real here, right? But I took it.
You got it and you took it?
Yeah, and I took it. So that means that you get a bunch of money, a startup package, you get a lab, and then they say you go teaching, you do some research here, and you prove that you're good.
So what was your plan for your research?
I mean, I had a plan.
What was this sort of...
No, so my plan was, which is a good plan, I had this idea that I worked on these proteins that were folding, right? And how fast, the question was like, how fast can it go? What's the speed limit for folding? And my protein has the speed, I have the world record in protein folding here because my protein is folding in 1 microsecond, 10 to the minus 6, it's nothing.
That doesn't say anything to me.
No,
that's
but
fast.
it's
quicker than a second.
Yeah, quicker in a second, much, much quicker. But anyway.
But do you mean that you can force it to fold?
No, it spontaneously fold.
But why is your quicker?
Well, I can measure the time. If you compare different proteins, how fast they fold, mine takes shortest amount of time.
Oh, yeah.
So other protein can take longer. I mean, in our bodies, proteins fold all the time, but they do it on many...
It's like a natural process.
Yeah, unless you get sick, because then we'll come to that. But then bad things can happen. No, so my idea was that we looked at the simplest proteins before, but most proteins in our bodies are more complicated. There's like a protein chain, but they also can have like a metal ion or some other cofactor, or there could be 2 chains. How does that, adding on these additional factors, affect the folding reaction? Because that's kind of, if you want to mimic living systems, you have to look at that. Every question you ask and answer, there are more questions. And you can ask so many detailed questions. What I do in my lab and still do, we make proteins. In principle, you use bacteria, and you grow a lot of bacteria that has your protein, the DNA for your protein inside. So then the bacteria makes your protein. Then you smash it open and kind of purify out your little protein. Then you have it in a test tube. And then you can use different techniques. Many times it's light in different ways. You shine light on the sample and you see if the light is absorbed or scattered or is sent out at a different wavelength. You can play with the light to understand what goes on in your sample.
Okay.
Because the protein, they're tiny.
Yeah.
They I'm not going to say...
It's nice to hear that the professor in chemistry describes proteins as tiny.
Yeah.
They're very tiny. But if we stop at the proteins now, because now we're in Houston, not in New Orleans.
Yeah, you're right.
So how did that happen?
From New Orleans, we moved to Rice. After 5 years in New Orleans, I actually got the promotion to tenure after 3 years, because I think they were worried I was going to leave because I was doing well.
All right.
It's kind of laid back.
Good.
They were really nice, the faculty at Tulane, my colleagues, but they were maybe not all of them the most stellar. But so they saw me as their kind of star coming in, the young person, the new person, and they
a new mind, a new set. Yeah.
And they supported me in a lot of things, nominated me for awards and so on. But I think they also saw less promoters, so nobody else tries to catch her. But I happened to organize a Chalmers University alumni party at my house in New Orleans. There was a bunch of Swedes, in the US that had gone to the university in Sweden, but they all came to this party and we had a gask, a big party with drinking and everything, lively party. But there was one professor, so there was one other person like me at this party, and he was from Rice University here.
Oh, yeah.
And he told me that, Pernilla, if you want to have a better salary, you should apply to other places. That's the only way to kind of try to bump up your salary. You try to go to another school and then say that you have another offer, and then you can get a better deal where you are. Send me your CV. So I did. And then the biochemistry department contacted me and said, we want you to come over and maybe interview you, or we might want to offer you something. And that's the time it's like, okay,
that's almost
Houston is in Texas. I'd never been to Texas. But then eventually I have to go and look at this place. Yeah. So I went here. And then when I saw Rice University, it was fantastic. Houston is such an international city. And the university is so much better than Tulane. so it just felt like, oh my God, this is great. And it's beautiful here, all these trees and yeah.
Yeah, it's a lovely place, absolutely.
So I loved it. And I felt like this is a step up for me. Better students. And that's also important, what type of students you have at the university. Because
is that like a challenge for you to be better when you have better students? Like if you got better students,
I become better too.
Yeah.
Because you are as good as your students are in a way. Because they do all the research in the lab.
Yeah.
So, you can do better with better students. I saw this as a
step up.
It's a step up, a new challenge, right? It would be harder for me. At the same time, my husband's company had their headquarters in Houston. So he had wanted to go here and, so it was great for him too.
You came to Houston back then and now we're at...
So that was 2003. The Americans here will know about some hurricanes, Katrina and Rita, that affected us, But so then we moved back to Sweden, 2008.
Why did you do that?
It was really... I had 2 kids, and the oldest daughter, she started school. So she went to kindergarten at an elementary school here, a public school, really good school. But that's when I realized, oh my God, if we stay here now, the kids will become Americans. And it's up to me, it's my duty to give them everything Swedish, like the Swedish traditions, the Swedish food. I got kind of scared a little bit. And I felt like, maybe they should grow up in Sweden because I have no clue about the American school system. How can I kind of help them? How do I get them into good schools? How do I, At the same time, my parents were getting older. There was so many things that I felt, we need to go back. So I started to look for positions in Sweden. Turns out that Umeå University in the north of Sweden, turns out that's the place where I was born also, long time ago.
Okay.
Anyway, they look for 7 professors in chemistry.
All right.
That is
so
really
from Houston
weird.
to Umeå.
Yeah. I went to look and, eventually I took the job because it looked really great. It was a great university in a small place. But
what was that like to come from Houston after 12 years to Umeå? There's nothing wrong with Umeå, but it's a difference.
It's a difference. First thing is very cold.
Yeah.
So the kids, everybody needs winter clothes, right?
Yes.
And my kids had never ever had like anything thick on them, right? These bulky things, I mean, they were before, I said, go out and test it, Eventually they learned how to wear it and just ice skating, skiing.
No.
They were not trained on anything.
No.
There, the kids would go ice skating on every break in school and daycare.
Yeah.
And my kids had to learn,
Yeah. So how long did you stay in Umeå?
I stayed 7 years. So now I've been 5 years, and now 7 years in Umeå. For me, I feel like that was the first, then there I became a full professor. So I felt suddenly I was senior. I got awards, I got funding, I became elected into the Academy of Sciences. I guess good things happened to me. Maybe because I was good, but also because, I became that person that, I hadn't been in the Swedish system for that long, and now things happened to me immediately.
And the Academy of Science is the Academy for the Nobel Prize.
Yes.
That's what we're talking about. Yeah. So
You're right. So you need to, so that's like the if you're very good, you become elected to the Academy. The Academy has 18 members in the class of chemistry. So you become one of 18. And then of those, you can pick 8 that goes to the Nobel Committee. So, and there's very little turnover on these things, right? So it's very hard.
You got your seat in the Academy. Yeah. How old were you at this point?
This was, I was 48, I think. This was rather young.
No, but also the recognition of what you've done so far with your life must have been.
No,
I can only imagine that that's sort of the.
No, but it's kind of interesting, right? Because that's a great achievement, right? And that's like
almost like the Hall of Fame.
But still, you can always see another level.
And what's that?
And then I saw the Nobel Prize Committee, right?
Oh, okay,
like
so
now I want to be
the Academy.
Then there could be other things you see. I mean, there's some grants in Europe I haven't got that I feel bad that I should have got the European Research Council grant. I tried many times, but I never got it. There's always a lot of failures.
So you have a big competitive mind also.
I think so.
Yeah.
And I think I don't know how far I can go. It's like I take one step, but
How far do you want to go?
I don't know. But the more I think about it now is that I want to make a difference. It feels like it should be worth it. I should have made it. My life should have been worth it in a way. You know, that sounds cliche in a way.
No, absolutely not. You want to leave a mark.
I want to leave a mark.
Or more, I would say, I'm not going to put words in your mouth about it's just that you want to find a purpose of why you're here.
Yeah.
Yeah. So I can see that.
Yeah. So I think that's, and that can be in many different ways. I think also this fact that as a professor, you train students, graduate students to get their PhD. You train a bunch of new scientists that can go out there, have their own career. That's maybe the most important thing I do.
Yeah, absolutely. But now, after these years in Sweden, you're back here in Houston.
Yeah, and it's a perfect timing, right?
Is this closer to your purpose? Is this where you feel that this is why I'm here? This is why I did all of this?
Maybe, maybe not. Maybe I'm not at the end point yet. You know, maybe I have to go more places.
No, I didn't mean that you're at the end point, but the feeling of coming back here.
There's kind of on different levels. One thing is the research that I feel like I want to be closer and closer to, like making a difference for people, meaning that you study diseases more than just general principles.
Yeah.
But the other thing is I felt I did a lot of things in Sweden. I mean, Sweden is a small country.
It is.
And it's kind of unique that you can, I mean, the academy is not unique, but we have the Nobel Prize in Sweden. So I got into that, and it was extremely interesting to see all of that, right? And actually be part of that and try to make a difference there. You know, you can't really say you should give a Nobel Prize to certain people, but I realized my vote matters.
Yeah,
I can influence.
What was it? 1 over 8?
Yeah. Then I happened to come by RISE because I was at a conference nearby, and somebody here invited me to give a seminar.
Oh, yeah.
And then suddenly a lot of vice presidents and prominent people wanted to speak to me when I was here. And I realized, they can do targeted hire, right? If they see some opportunity. Yeah. And my head was ready for that. You know, it's been so nice. As I came back last summer, so I've been here half a year now, a little bit more.
So it's quite recent that you got.
Oh, yeah. We're still new. I'm still new. I mean, and we're still building up the labs and everything, but everybody's been so welcoming.
Yeah.
You know, want to help me and say, oh, you're here now, Pernilla, we heard of you, you know, like, welcome, you know, anything, you know. It's really nice.
Maybe that's where you're going to see your purpose in this.
Yeah.
Maybe that's what's happening now.
I think so. I mean, it's like, and then I'm recruited to do my research, right? And we can talk about why I have this one here.
Yes.
And why, you know, I got all this money to work here, but it's really the place to be. And me doing basic science, you know, it's things in test tubes in the lab, to have like doctors and medical people with like, I don't know, patient material and all kinds of data. It's great.
Is that an open collaboration between those groups and between those faculties?
You have to find each individual collaboration, but I see the universities do many things jointly too. Yeah. And they set up kind of funding opportunities to work together. So I haven't set up any collaborations yet, but I can see potentials, right? And I started to meet with people, but first I need my own stuff get going. And it makes a difference to collaborate with somebody across the street so you can see them face to face.
Yeah. To have a real connection. So now you're here, and I know you're into proteins.
Yes.
That's your thing. You got proteins on your arms. Even.
Yes.
Yeah.
So in principle, you know, I started out doing protein.
I got proteins in my arms.
You have proteins in your arms, right? So you have other tattoos, but you know, so I started doing protein folding, and then the more senior I get, you know, we talked about the metals and the things before, but I started to more look at when protein folding goes wrong, and that causes diseases. In principle, all diseases we have are linked to proteins doing something wrong.
What do you mean all diseases?
Because
you mean all diseases?
Yeah. Every disease you have, it's a particular protein or set of proteins that misbehave. Because protein,
You mean all diseases?
Yeah.
Oh, wow.
Yeah, I mean, you can have genetic, you know, inherited diseases that, you know, there can be DNA problems in the genetic material, but that means that the protein is wrong that you make from that genetic material. So in the end, proteins do all the work in our bodies.
All right.
So they cause all the problems. And then many times when you have a mutation in a protein or somewhere, and then the protein is not functional because it doesn't form that globular structure. So it's kind of just floppy. And then it doesn't do its work. So you have a lack of function, and that's a disease. And many diseases. And then you can try to supplement it with something. But the diseases that are increasing in society today, neurodegenerative disorders like dementia, all types of dementia, Alzheimer's, Parkinson's, ALS.
It's proteins.
Their proteins misfold and then they become toxic. So there's gain of function. They start to aggregate together and form. And that's why I have this here, this long kind of stacked fibers that we call amyloids on scientific, but plaque in the brain. Most people have heard of that.
Yeah.
So the proteins start to form these long fibers that clog your brain cells.
Oh yeah.
And that's and they have toxic functions, these plaques, so they destroy your brain cells and they die. And therefore you don't have memories and you can't function as normal.
But this model that you have here,
Yeah.
is this a faulty protein? Is
Yes.
this, yeah.
So one of these, actually, you can take this apart. So one of these pieces is actually a chain of protein
Yes.
that has a normal function as an individual protein here.
Oh, this is a normal protein.
Yeah. But it has a different shape, but I can't really bend this one.
No? Okay.
Yeah. But then when things go bad, when you get Parkinson's, this protein start to assemble into these it's beautiful structures like this. And they can be long, very long. So thin, long things. I can see them under my microscope.
Yeah.
And
Really?
You can extract them from the brain of dead patients, but you see them in the brain. So there's a direct link between this protein and Parkinson's.
So they stack together and get longer and longer.
Yeah.
And when they do that, they sort of make everything around them in the brain not functioning anymore.
And that's the question. Maybe that is the whole truth, but maybe they do more things. So we have found, for example, some new things we discovered is that when they make these long things can actually do certain chemistry on the surface. So they can change things in a cell. A cell is full of metabolites and all kinds of little molecules, DNA and other proteins. These seems to be able to change that, to catalyze chemical reactions and maybe mess up the cell even more. Then you have a physical problem that you kind of poke on the cell walls type of things. So we don't really understand what is the toxicity things that these do. We know this cell dies.
Are you close of stopping it? Do you know how to stop it?
No, that's a big, big problem with neurodegenerative diseases, Alzheimer and Parkinson's. The number of patients in the world is increasing. And why is that? That's because people get older and older. We live longer and longer, which is real. Yeah, we do.
So that's okay.
And age is the largest risk factor because this comes with age. You're more and more. Yeah.
It's a mathematical thing, really, because you get older and you open the opportunity for.
And then some are more prone than others to these things, but most of it is sporadic. So it's not a genetic component. It just happens. And we want to find out, is that something else, right? Is it something we can prevent earlier? But we don't have any cures. We have some medicine that kind of hinders symptoms for some degree, but it's a huge societal problem.
Yeah.
To pay for like homes for all these people or care, if nothing happens, right? If we just live longer and longer, we will all be in some kind of.
And it's also a very tragical disease too.
And it's kind of scary to everybody because you lose your mind, right?
Yeah.
So Texas is really into this now. And that's one of the reasons why I'm here too, is that the Texas state is putting out a lot of state money for dementia type of research. So that is not out yet. They approved the bill in the fall, but it's going to be a lot of funding to recruit people to Texas to fund different projects around dementia. And that's where my work comes in also, because this is what I work on. The money that I got to come here is truly for cancer research, which is also a terrible disease.
Which is also proteins.
Yeah, which is also proteins.
Because all diseases are proteins.
Yeah. But in that case, you have proteins that help the cells divide and make more cells. So then you live too long, right? Because tumors are too many cells. You don't want them.
No.
But then proteins do bad things to kind of cause that to happen. So we look into that too. And there it turns out the metals are very important. Copper ions is a metal that promotes cancer metastasis. So we found that one protein, this is a protein I have here, it promotes metastasis or spreading of cancer. So if you can stop this protein, and it has a little metal ion. Can you see the little ball?
I see it.
Then maybe you can stop spreading. Because we have a lot of medicine for cancer today. But as soon as you get metastasis, it's really hard.
Yeah.
So that's what I'm focusing on now. But what's kind of, to me, like really cool about that is that there are actually proteins in cancer that are oncogenic then and drives cancer. They seem to form amyloids like this. Mm-hmm. There's very little done of that. We didn't know that before.
It's connected.
Yeah. So I think that by understanding how proteins come together, how they behave, misbehave, what that can lead to, what type of structures and what type of things these can do, we can solve all these diseases.
To simplify all of this.
Yeah.
You want to stop this from happening. That's what.
Yes.
Is that the aim of your research today?
I mean, in principle, but at the same time, I want to stop it because I can help curing the diseases, or I want to stop why it wants to happen in the first place. So then there might be another factor I should target. That is the first bad thing that happens and then makes this happen, right? So you have to find that kind of, oops. Oh my God, I get crazy here. Yeah. You have to find kind of the best target here.
Yeah.
But at the same time, I want to understand how these things happens, because you learn about basic kind of biochemistry, biology, what is possible in nature, right? Because these types of things, these long fibers or amyloids, some of them in some organisms can be functional. So you can think about, if I know more about this, I can design something like this that can do remediation out in the world, or clean up somewhere, or break down plastics, or I can think about this for some other purpose.
Even that.
So it could be like a material, a biomaterial. So,
wow.
So there's many kind of things, and I mean, how can these proteins decide to fold up into these different structures? I mean, there's so much like basic understanding of kinetics, thermodynamics, structures and things. And I think I'm triggered by the questions, really. I want to find a cure, but I'm not going to make the drug. I'm going to do discoveries that says, you over there, you go and make a drug to this target. I give you my target. But I want to kind of...
Would it be possible to, I know that I'm in a little bit of deep water now, but would it be possible to sort of skip the drug and just to change the protein?
Yeah, but then you have to go into your brain and change it in all your brain cells, and that's the problem.
So you need a drug to do that for you in a way.
And you could use some of the like engineering, or like if you can mess with the DNA, like one of the Nobel Prizes we talked about, where you can cut and paste in DNA. But it's really, you can't, it's very hard to get into the brain. And that's why it's hard with anything in the brain, because we have something called the blood-brain barrier. So, and you can't get into every single cell.
No, that's...
you could think about manipulating things in an embryo before, a baby's born, but then you're into very controversial things.
Yes.
And we don't know enough to do that.
No.
So
maybe we
you
should.
have the proteins you have, and they are there. And the brain cells, the nerves in the brain, they are there for a very long time.
Yeah.
So, you have the proteins, and they don't really regenerate. So it's hard to address that.
Yeah.
And then many of these proteins that form bad things in diseases, they have a normal function. So you can't just remove them, right? Because then you lose a function.
Yes, of course.
Yeah.
Then you start messing with things that you don't want to mess with.
Yeah. So you also want to know what's the normal function, or how much can you manipulate? And many times the body life is so beautiful. We have so many backup mechanisms and regulations of different things. So it's tricky when you start to change things. If you change one thing, something else goes up. And so there's still a lot to understand. I think that's something as a scientist, you learn more and more, or you see more and more. There's so much that we don't know. First you think, we all know all this already, all of that, and what's left for me to solve. But there's so many things we don't know.
Isn't that the starting point of being a researcher or a professor or a scientist? We don't know.
Yeah.
Yeah.
No, and that's it. But still, you need to know a little bit if you're going to get
funding. Yeah, but we don't know. That's what we're trying to find out.
Yeah.
And when we found this, we still don't know this.
Yeah. So and that's why I'm doing these proteins now, because every kind of discovery I make, it takes me to the next level. And I walk through, if I look back at my publications, or my type of the research I've done, it's kind of builds on each other, right? And then there's a coincidence. Somebody tests something like this, something weird happens. We follow that. Oh my God, we're into cancer now, or now we're into this, or metals matters. Then we look at metals more. And, so you kind of follow what happens.
Yeah.
Or follow the data, as you can say.
Don't you think that you're sort of close to your purpose now?
Maybe.
Because when I hear you talk about this,
Yeah.
I see that you're like a conductor almost. That's guiding people in the right way.
Yeah.
That's what I hear.
No.
Guiding
and
students and colleagues in the right way to see if they see something that we don't know.
And I think and then be there with a helpful eye to kind of see, this is interesting, you know. Don't say it didn't work. That is interesting. Follow up on that. And I think that's what now coming here, it takes some time to build up.
No, but of course it's going to take time. Then you need to find sort of the team
but
spirit.
I think this is what I like to do.
Oh, yeah.
And in Sweden, there's so many meetings in Sweden. You know, you just sit in meetings all the time and you talk, and there's no way to know if it's everybody's for or against, because they have this monotonous voice. And you have another meeting and you wait for some consensus to come in. And I just felt I was sitting in meetings all the time. We don't do that here. Maybe sometimes, you know, we go too fast here and we just decide something that I should have asked other people about. But it's a beauty to that too.
Yeah.
That you have some power. I want this to happen now, and then it happens.
But that actually leads into the final part of our conversation. Because we talked about purpose. We talked about changes. You've been moving, and you're from Sweden.
Yep.
Which part of Sweden are you from?
I was born in Umeå.
But you told me. Sorry about that.
But I grew up in Gothenburg, or outside Gothenburg, Mölndal.
So what we have on the table is the map of the world.
Yeah.
And we're somewhere south of Dallas.
Yeah.
Because that's marked.
Yeah, it's marked there, yeah.
And this is Sweden. And you live there, and there.
I typically have this map when I introduce my talks and things, and I tell students where I've been. I have these arrows going back and forth all over the world.
So where is home?
It's a very good question. And I mean, I still think I feel Swedish, but when I moved back to Sweden, I always felt different wherever I am. When I lived in the US, I felt like I was different because I was a Swede. Then I moved back and everybody expected me to be a total Swede because I am Swedish. But I had all this history in the US.
Americanized in a way.
And I Americanized in my way of talking or being, or, you know. So I behaved. I didn't know what TV shows I look at. I didn't know how to dress. I didn't know like what's within the normal limit of being a Swede.
No, but the everyday culture is.
Yeah. So I always felt a little bit different there. And sometimes I've been being back for 17 years. I worry that, you know, I shouldn't say lazy, but like that I let go of my drive in a way. Because in Sweden, you know the word lagom. Yeah. Everything is good enough. And you don't really push for the edge of things. I mean, I'm putting everybody over the same.
No, but there's a difference in everyday culture.
There's a beauty of that too, because you also have more time for hobbies or free time, and you go home after work and you do other things, right? But then now, so I never felt really like a real Swede. And now when I'm back here, I feel more of an American now than the first time I was back.
So if you make a choice, where is home? Could you write your name close to that point on the map?
This is really new. I'm going to get a lot of critique whatever I do. You know, politically correct, I would write it over here next to my kids in Lund.
Yeah.
But they don't want to stay in Lund, right?
No. But I'm asking you, I'm not asking your kids.
I know, but they might listen to this. You know?
Yeah, they might. Where is home to you now?
I mean, it is here.
Yeah.
I feel good here. I can't write on this. I feel good here. I brought my cat here. You know, I feel at home. And I've been back to Sweden. I'm
not really done now.
Yeah.
So if you were to write a letter from here.
A letter? Okay, a letter, yeah. Mm-hmm.
To where you came, which is Umeå.
Yeah.
What would that say?
Oh my God. You know, to me in Umeå, or to...
To whatever Umeå represents to you. The city of your birth, you know, you're growing up. If you were to write a letter from where is home now to Umeå,
I think, actually now my old teachers in Umeå that I had when I was little are dead. But my nanny in Umeå that I had when I was young, she I think she follows me on Facebook, you know. I think Umeå would be very proud of me where I am today. And I should be proud of myself too, because I could never have guessed that I would, be here now.
I'm going to ask you again now. So if you were to write a letter from Warriors Home to Umeå, what would that be? What would you say?
I would say, come and see me.
Come and see me. Oh, that's
Come
right.
and see me. I would say so because actually that's a very good point. I can say that to many people because I think Texas and Houston is like a hidden gem. You if you haven't been in here,
No.
you have a kind of a view of Texas as something. You think about cowboys, you think about certain things. But when you get into Houston, actually Houston is the diversity of the whole world in one city.
Yeah.
So people do experiments on Houston just because it's a way to represent the whole.
I didn't know that.
Yeah.
No.
So it's a really good place for some type of population experiments.
To come and see me.
Yeah. Come and see me, please.
And I know that you didn't like the pen, but I'm still going to force you to write your name here on the map because I want your signature on the map.
Okay, I should do on the water?
Wherever, yeah. We can draw a line. Maybe I need to buy a new pen.
Yeah. Maybe you should try the pen you got from me.
Yes, maybe. Thank you, Pernilla. It's been a pleasure talking to you.
Thank you very much. It was fun.
It was fun.
It was.
Let's do it again sometime.
Yeah, let's do it again next time you come around.
Yeah. Thank you. It's been a pleasure.
Thank you.
You have listened to Letters from America, a weekly road trip podcast celebrating the Swedish heritage in the United States. Produced in collaboration with the Embassy of Sweden in Washington, D.C., Volvo Cars USA, Volvo Trucks USA, and Airstream.